Hello everyone. This video is for the mechanism sessional assignment number 5. My name is Abhishek Ranjan, roll number 20 ME 10004.
My name is Mohhit Kumar Jha, roll number 20 ME 30084.
And my name is Srijan Agrawal, roll number 20 ME 30063.
For this assignment, we have chosen uh, the first question of the assignment.
Uh, just a minute, we are sharing the screen.
Okay. So we have chosen this first question to synthesize and make a simulator for the windscreen wiper mechanism. So a wiper is used in cars and trucks to wipe out rainwater, snow, and other fluid stuff that might have fallen. So a wiper is basically like it consists of a metal arm, and one end pivots and the other end has a long rubber blade attached to it. The arm is powered by a motor, uh, and some vehicles some other power is also used. So this is the mechanism that we have made. Okay, Mohit.
Reset कर दे एक बार.
So we can just reset it and show it to you. So this is the mechanism. Here you can see that the area wiped is being shown in blue color and the mechanism is being shown. Here the crank is driven by a motor, which we can see here. And over here we can see the graph of velocity versus time and the graph of acceleration versus time. And the velocity and acceleration refers to this point here, which is the center of this mm, wiper shaft. And we can also visualize velocity vectors, which is something like this. As you can see here, the velocity vector, which is visualized in green color, and the acceleration vector is visualized in dark pink color, and the components of tangential acceleration and centripetal acceleration are also visualized in light pink color here. So now Srijan will explain the working of the mechanism.
So yeah, so basically we tend to maximize the area, and we tend to find how crank length, how coupler bar length affects the area wiped. And we'll simulate for various lengths, and we will find out how does the length affect the area wiped. So first let's simulate the crank length. So here, if we take a crank length equal to 0.1, then we can say area wiped is 7.22 meters square. Now slowly we'll increase. Now area wiped is also increasing, 7.73. Now we have increased it further, 8.823, 8.73. So with this we can conclude that with increase in crank length, there is a increase in the area wiped. Now what we can do is, now we will check for the coupler bar length. So for the coupler bar length, we can start from some length like 2.6. So for 2.6 meter, the area wiped is 7.73 meter square, as you can see here. And then as we increase it, the area wiped increases. So for the coupler bar length also, if we increase the if we increase the length of the coupler bar, the length of the area wiped also increases. Now we will see for the output bar length. So for the output bar length, we will start from 1.6. Yeah. So for the output bar length, if we start from 1.6, now we slowly increase it. Now here 7.32 is there. When we get 7.39, then 7.43. For 2 meter we get 7.46. For 2.1 we get 7.47 meter square. Now here we have to notice something. As we go for 2.2 meter, we get 7.47 meter square, and for 2.1 also we were getting the same result. And now when we exceed 2.2 meters, we are decreasing with the area wiped. So that means like there is a maxima here in the output bar length. So for the output bar length, if the crank length and the coupler bar length is fixed, then there is a certain output bar length for which the area is maximum, like the area wiped is maximum. So for 0.4 of crank length and 2.5 meter of coupler bar length, we have output bar length equal to 2.1 or 2.2 meters, for which the area wide will be maximum for the particular assembly. For the delta angle, we can see that if we alter the delta angle, suppose we are altering it to suppose minus 30 degree, and now we can see another here the area wide is 7.47 meter square, and now we can see the other extremity, suppose 18 degrees. Here also area is 7.47 meters square. So with the delta angle, there is no change in area wide, but however, the position of the area wide changes. So like if for 18 degrees, it is wiping here. But like if we go for minus 23 degrees, so the position of area wide changes. It is wiping here. The same area is being wiped, but it is at the different position. For the wiper bar length, if we like decrease the wiper bar length, so area wide increases, but the angle remains the same. The angle of the area wide remains the same. So for 2.5 meter, if we decrease the bar length to 2.5 meter, so the area wide is 4.67 meter square, but the angle of area wide remains the same. So like when we increase to 4 meter, so the area wide increases, but the angle remains the same. So this is some specific angle of area wide. Now Mohit will explain the code and the like all the dynamics of how the code works.
So the code is mostly written in JavaScript, and the styling has been done using CSS and HTML. So here I'm showing you the script which is actually used for writing the mechanism. So first of all, we are defining certain parameters or variables here. As you can see, there are different parameters such as omega, which is used for angular velocity, and we have specified the pivot of the motor, which is at the location at the coordinate 3 comma minus 2 with respect to the center of the canvas. We also have this delta angle which we showed you earlier, and these arrays are used to store the path of the points made by the wiper. Now as we move ahead, we also see different variables for different parameters which were there, such as the motor bar length or crank length, the coupler bar length, rocker bar length, etc. So we are just initializing variables here. Now once we have done that, we move ahead and we see that we have defined our coordinate system. So the coordinate system is mostly based on this image here. As you can see, this was the question number tutorial sheet 2, and this is question number sheet showing a mechanism of wiper. So we have used all the coordinate system as given in this figure. As you can see, this is the ground joint O2, and there is this ground joint O4 and O6. We also have these joints A, B, C, and D. So these are the 7 joints and the links which are used to create this mechanism, and we have used similar notation in our code, and we have just defined all the lengths here, as you can see. Now in order to get the area wiped, what we do is that we calculate the maximum and the minimum angle made with respect to O4. As you can see in O4, if I go here, you can see this hinge is actually O4, and there is this maximum of O4, there is this maximum displacement of O4 angle, and there is this minimum displacement of O4 angle. So what we do is that uh, we create a variable max O4 which stores the value of maximum angle made with respect to O4, and similarly we may have a variable min O4 which stores the minimum value with respect to O4, and the variables have been initialized above. Now we will get the angular displacement as max O4 minus min O4. So this is the total displacement made by the output bar length. And now since we have got the maximum displacement, we will get the arc length using the length of using the angular displacement multiplied by the output bar length. So in the simulation you can see uh, this is the output bar. So this multiplied by the angle gives us the arc length which is being traversed here. So once we get the arc length traversed here, we just need to multiply it with the length of the wiper bar. So this is the wiper bar and this is the arc length. So if we multiply these two values, we will get the approximate area which has been wiped in this, which has been shown here in blue color. So and the calculation is done here and it is represented here. So this is what we calculate here, and now we handle when motor behaves as a rocker. So for some values, motor won't be able to rotate freely, and it will not behave as a crank. Rather, it will behave as a rocker. So for that purpose, we need to uh, change the working of the motor so that we do not get any unknown values. So that has been fixed here, and now we start with drawing our canvas. So first of all, we draw our ground, as we can show you parallelly here. So we can see drawing the grounds, and now we have also uh, drawn base bar, etc., motor bar, coupler bars. So everything we are just drawing here. Now once that has been done, what we do is that we use vector mechanisms to generate the path which has been traversed by this wiper. So if you can see, this motor is the crank which is rotating. So we know the coordinate of this length, and we also know the lengths and the positions which of all the other lengths. So if we know all that, we can use vector mechanics to finally find out what is the position of this point here, and that's what we get save as our path, and these paths are being pushed in an array so that we can visualize it. And now once we are done, we again draw some other parts such as the wiper, etc. So once they have been done, uh, we use a few other code to just go through and label these parts, such as there is a label for a motor here, and there is a label for the delta angle here. That has been done. And once we are done, we come to the velocity and the acceleration analysis. So first we compute, like, we have a function with respect to time which computes the angular velocity of the motor. So once we have the we determine theta as o2 plus omega times time, which is actually the angular displacement with respect to a given reference. Now this data motor actually stores the velocity at a certain time, and similarly when we go for wiper bar, we use again vector mechanisms to finally get a data wiper which stores the value of velocity here, and this velocity is actually visualized using this button, which is the velocity vector. As you can see, this is being visualized here. And now once we have done, we have this scaling factor which does nothing but just scales down the velocity and acceleration factor so that they do not go out of bounds in the canvas. Now once we are done with that, we can see visualizing the velocity vector which we calculated earlier. So this is being done here. So we are visualizing the velocity vector, and once we get the velocity vector, uh, we do acceleration analysis for the wiper. Now this acceleration analysis is nothing, it is just the differentiation of velocity. So that is being done here. Now once we do all that, we just need to update our canvas again and again. So for that purpose, we have this update button which updates the different buttons there. So this is update velocity button. So what it will do is that whenever I click this velocity vector button, it will just update the image here. And similarly, now further we have this reset button. So it implements this reset functionality here, and when we click on reset, we can see that our mechanism is has been reset to its initial position. Now we can again go for start mechanism, and it will again start wiping the area. uh, Now as we move further, we will just see some other helper function which will help us to set the value of omega to the desired value when we change this scroller here. And similarly, there are some other scholar settings here which have been done. And and this concludes our code. Basically, as you can see, this is the end of our code. So this has been this is what we did to implement. And for showing these images here, what we are using is a latex image generator. This is a package which is used to create simple images. So we just need to give the kind of image we need to generate, and it automatically renders it on our screen. And now we are done with the code.
So we would like to thank Professor and TAs which help us during this project, and we are very thankful that we got this project. And this was a very good project, and it intrigued us with a lot of thoughts, and also we got to learn about mechanisms through it. So thank you all.
Thank you.
Thank you, everyone.